everyone, myself Sravanthi, working as the Assistant Professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is grammar. So here I am going to discuss what is a grammar, what are the types of grammars, and what is how we are going to write a grammar, and what is the production rules, and what is the non-terminals, and what are the terminals. All these things we are going to discuss over here. So first let us learn what is a grammar. So grammar is nothing but here a finite set of rules. By applying some rules, we are going to generate some valid strings, or set of strings are generated within a language by applying some set of rules. Then we are going to call it as a grammar. So mathematically we can show that grammar is nothing but it is represented by V comma T comma P comma S. So it is nothing but V comma G is pointing to grammar, and V comma T comma P comma S. So this is nothing but the mathematical representation of a grammar. So what is V? V is nothing but it is a set of non-terminal symbols or variables, or we can also call it as it will be represented, or it will be there in the form of a capital letters. It will be in the form of capital letters. T is nothing but the terminal symbols. So terminals are nothing but here the small letters, or nothing but we can call it as a lowercase letters or plus, minus, all those things comes under the terminals. Small a, small b, 1, 2, plus, minus, all these things, comma, all these comes under the terminals. So here the V intersection T is pointing to null. So nothing but V is nothing but the non-terminals, and T is nothing but pointing to the terminals. So it is pointing to pi, nothing but empty. So V intersection T is nothing but null. So S is the start symbol. S is nothing but the start symbol of my grammar. So production rules. The production rules are in the form of alpha produces beta. So nothing but I can tell the production rule as LHS produces RHS. Wherever in the string, if I find the LHS, these LHS can be replaced with the RHS. Nothing but we are going to call it as a production rules. We are going to call it as a production rules. Let us assume it as alpha produces beta. Alpha produces beta. So LHS consisting of only single one, that is nothing but the single non-terminal will be there, and the RHS will be consisting of a non-terminals or terminals, or we can also have non-terminals, terminals, and we can also have epsilons also. So this is nothing but the RHS part can be a combination of non-terminals and terminals, or it can be a terminals and non-terminals, or we can also have a terminal, or we can also have non-terminal, and we can also have epsilon also. But coming to the LHS part, we will have only one point, that is nothing but only one thing, that is nothing but the non-terminal. Let us see here one example. A produces 0, 1, A. See here, A produces 0, 1, A. A is nothing but the non-terminal. It is in LHS part. And coming to the RHS, 0, 1, A. 0, 1 is nothing but the terminal, smaller case letters or lower case letters, and A is nothing but the non-terminal. It is a production. And this is also one type of production. Here A produces B, and we can also have, if we want to write more than one production in a same line, will be using oblique or nothing but hash of same production of LHS. A produces B, or A produces A, and B produces 1, 1. So this is nothing but a production rule. So when we talk about the S starting symbol in the given production rule, the first production rule we will be calling it as the first production rule. The LHS part non-terminal will be our start symbol. In any grammar, we will have only one start symbol, and we can have multiple final states as we have discussed in the finite automata. So in the same way here also, we will be having only one start state. So that is nothing but the first production in the LHS part, the non-terminal, we are going to call it as a start symbol. So these are nothing but the few production rules for this given grammar. So V is pointing to the non-terminal symbols, nothing but the capital letters, and T is pointing to the terminal symbols, nothing but lowercase letters. S is the start symbol. That start symbol is written in the production rule. The first production rule LHS part will be our start symbol, and these production rules are written with the help of these terminals and non-terminals. The production rule will be in the form of alpha produces beta. So there are different types of grammars are there for us. So one is nothing but the types of production rules by applying Chomsky rules. Nothing but the some classes are divided into these four things: type 0, type 1, type 2, and type 3. And the next one is the derivation trees, ambiguous grammar and unambiguous grammar. And we can also have basis on the number of strings. We can call it as recursive grammar or non-recursive grammar. By looking into the production rule, we can tell that the whether we can generate the number of strings, infinite number of strings or finite number of strings, will be discussed here with the recursive grammar and non-recursive grammar. Coming to here, ambiguous grammar and unambiguous grammar is nothing but if we derive more than one parse tree, then we can call it as nothing but more than one parse tree or more than one derivation tree. We can call it as ambiguous grammar. If we are going to generate only one derivation tree for the given string, then we can call it as unambiguous grammar. So the classification of grammars. So in 1959, Noam Chomsky introduced the classification system for grammars based on their complexity and expensive power. So nothing but the classes of grammar, we can call it as Chomsky's hierarchy. So there are four types of grammars are there here: type 0 grammar, type 1 grammar, type 2 grammar, and type 3 grammar. So the first grammar we are having is the type 0 grammar, that is nothing but unrestricted grammar. So here we can have any string of terminals and non-terminals on either side of the production arrow. So nothing but here we are going to discuss here the production rule. Actually a grammar G is consisting of V comma T comma P comma S. So here the only the production rule will be different when coming to the variables or non-variables and terminals and the start symbols are same for the grammar which we have discussed. So in the same way the only the production rule will be differ in the types of grammars and also recursive grammar and non-recursive grammar. Only the production rule will be differ. So here the production rule, let us assume the production rule is in the form of alpha produces beta. Alpha is nothing but LHS produces RHS. So here the rule is nothing but here we can have any string of terminals and non-terminals. We can have any number of terminals and non-terminals on both the sides. Then we can call it as a type 0 grammar. Nothing but we can call it as unrestricted grammar. We can also call it as unrestricted grammar. Here the only thing here we are need to keep here is alpha should not be empty. Nothing but the LHS should not be empty. So this is the only grammar we can have in LHS and RHS. We can have any number of terminals and non-terminals. Here alpha and beta can be any string of terminals and non-terminal students, and as long as alpha is not empty. If alpha is empty, then there is no production rule and we can say that this is invalid. So here if alpha is not empty, then it is a valid production and we can call it as a type 0 grammar, or we can also tell it as unrestricted grammar. So let us see here. LHS part I am having two terminals and two variables and one terminal. A is the terminal and these two are pointing to the non-terminal, and C and S. So this is nothing but this is the non-terminal and this is nothing but the terminal. So we can have any type of productions here. As there is no restriction that LHS should have only one and RHS can be have anything. So here in the LHS and RHS we can have any number of terminals and non-terminals. So that is nothing but type 0 or unrestricted grammar. So the next one coming to the type 1 or context sensitive grammar. So here the grammar in this is nothing but the little restricted grammar when compared to the type 0 grammar. So this is nothing but the context sensitive grammar, or we can also call it as type 1 grammar. A grammar G says to be CSG is nothing but context sensitive grammar if the productions are in the form of alpha produces beta, where alpha comma beta belongs to V plus T whole star, where alpha comma beta is a combination of nothing but alpha comma beta belongs to V plus T whole star. So the type 1 or the context sensitive grammar should satisfy the given production that it should not have beta should not be empty, beta should not be empty, nothing but it should not have epsilon. Suppose I have A produces epsilon. So this is not a context sensitive grammar. Why? Because according to the rule, beta should not have epsilon. Alpha produces beta. So the beta should not have epsilon. And the next one is alpha and beta. So the length of alpha should be less than or equal to length of beta. So nothing but here what I can tell is the alpha can have the less when compared to the beta, but alpha, the length of LHS should not be greater than the length of RHS. We can have the same length, or we can have less in the LHS and we can have more in RHS, but we should not have the length of LHS should be very less when compared to the RHS. It should not have more in the LHS. If that is the case, then that is not a context sensitive grammar. We can tell that the context sensitive grammar is nothing but it is a type 1 grammar, and it will be in the form of alpha produces beta, where alpha and beta can be a combination of terminals and non-terminals. It can have terminals and non-terminals also. V plus T, either V or T should be there. So V plus T, we can have combination of terminals and non-terminals. See here, capital SAB produces CAB. So here the last two letters are same. Here the S I can replace it with C as it is followed by AB. So here A produces epsilon. So this is wrong. According to the rules, that the first rule is nothing but the beta, nothing but the RHS should not be epsilon, and the length of the alpha, length of LHS should be less than or equal to length of beta. For example, A1 produces B. So is it correct here? It is wrong. Why? Because the length of LHS is 2 less than or equal to length of RHS is 1. 2 less than or equal to 1. So it is wrong. So nothing but, so this production is not accepted by context sensitive grammar. So the next one is context free grammar. So we can also call this context free grammar as CFG. So here if all the productions are of the form A produces alpha, where alpha is nothing but it's a combination of variables and terminals. Variables are nothing but the non-terminals and terminals, capital letters and lowercase letters. So these are most commonly used in the compiler design. Mainly these context-free grammars are mostly used in the compiler design. Here the production rules are in the form of A produces alpha, where capital A is nothing but A produces alpha. A produces alpha. A is nothing but the LHS and alpha is nothing but the RHS. LHS will have only a single non-terminal. Either any letter, anything can be there. That should be only one. The non-terminal should be there. Non-terminal is nothing but it's a capital letters. And alpha can be any string of terminals and non-terminals. We can have here the alpha can be any string of terminals and non-terminals. So this is nothing but the context-free grammar. Let us see here. S produces ASB or S produces epsilon. So we cannot have SB produces some AS. So these type of strings are not accepted. Why? Because in the LHS we should have only one non-terminal. It should have only one non-terminal. There should not be any terminals in the LHS part. Coming to the RHS part, it can be a combination of terminals and non-terminals, and we can also have zero occurrences. Nothing but epsilon can also be there. So according to this production rule, it is going to generate A's followed by B's. So nothing but it is going to generate AB or AABB, or nothing but it can also generate null strings. Let me check here. S produces ASB. So here the S produces ASB is nothing but AB, A epsilon B it is going to generate. So nothing but the strings it is going to generate is AB it is generating, and also I can generate ASB is nothing but ASB B AA epsilon BB. So nothing but AABB it is going to generate. S produces epsilon. Epsilon is also going to generate. So it can generate many strings here. It is in the form of A power and B power. So both A's and B's are equal over here. So this is nothing but the context-free grammar. So the context-free grammar is the type 2 grammar. So coming to the type 3 grammar, that is nothing but the right linear grammar. And we can also call this right linear grammar as the regular grammar. So a grammar G is said to be regular grammar if all the productions contain either left linear grammar or right linear grammar, then we will call it as a right linear grammar. Either is nothing but here, either in my production, I can have either right linear grammar or I can have left linear grammar, but it should not be a combination of left and right linear grammar in the given production, in the given grammar. So we can have either the left linear grammar or we can have the right linear grammar. But it should not be a combination of left and right linear grammars. If this is the case, then we can tell that it is not a regular grammar. To tell the given grammar is regular grammar, we can have either leftmost derivation, leftmost left linear grammar, or we can have the right linear grammar. But it should not be a combination of left and right linear grammar. That is nothing but the type 3 grammar. The production rules take one of these forms. A produces AB or A produces A, where A and B are nothing but the non-terminals and A is pointing to a terminal. So see here, this is nothing but what type of grammar it is? It is a right linear grammar. It is a right linear grammar. So how I am going to tell it is a right linear grammar? The non-terminal is present in the right side of the RHS part. Then we can call it as a right linear grammar. When we'll call it as a left linear grammar, when the non-terminal in the RHS part, if it is present in the first phase, then we can call it as a left linear grammar. Left linear grammar. If the non-terminal is present in the RHS part, then we can call it as a right linear grammar. So this string it generates like A, B, A, B, or just B. Some set of strings it is going to generate. So this is nothing but the right linear grammar, and it is the type 3 grammar. We can also call this right linear grammar as a regular grammar. So this is nothing but the relationship among grammars classes. So Chomsky hierarchy visualized by using some nested circles here. So the type 0 is nothing but the unrestricted grammar. This is nothing but it is consisting of large set of grammars. Here the LHS and the RHS can be any number of non-terminals and terminals. It's a combination of non-terminals and terminals, LHS and RHS in the production rules. Coming to the context sensitive grammar, it is nothing but a little bit sensitive when compared to the type 0 grammar, a subset of type 0 grammar. And the next one is nothing but the context free grammar, that is type 1 grammar. Here in these production rules, the LHS should have only one non-terminal, and RHS can be a combination of terminals and non-terminals also. Coming to the right linear grammar. So this type 3 is nothing but the right linear grammar, and we can also call it as it is a subset of type 2 grammar. And this right linear grammar we can also call it as a regular grammar. Here in this regular grammar, we should have the production rules. Either it can be in a left linear grammar or either it can be a right linear grammar, but it should not be a combination of left and right linear grammars. So here the type 3 can be a combination, or it can be having type 2, type 1 and type 0. But the type 0 grammar cannot be a type 3 grammar. It won't have a type 3 grammar. This type 3 grammar is nothing but it's a subset of type 2 grammar, it's a subset of type 1 grammar, and it's a subset of type 0 grammar also. But the type 0 grammar is not a subset of type 1, type 2 or type 3. So this is nothing but the visual nested circles of all these 4 grammars. So according to the Chomsky hierarchy. So the next one is grammar. So grammar is divided into 2 types, which I have shown you: left linear grammar and right linear grammar. So what is left linear grammar? As I told that the grammar is consisting of 4 tuples v, t, p, s. All these variables, terminals and start symbols are same. Only it differs in the production rules. Only it differs in the production rules. So the production rules is nothing but here, where alpha, beta is nothing but belongs to the terminals. So here, what is a left linear grammar? In the left linear grammar, the LHS part, let me take here, LHS produces the RHS. In the RHS part, the non-terminal should present in the left hand side. The non-terminal, only one and one left non-terminal should present. That non-terminal should present at the left side of the RHS part. Then we can call it as a left linear grammar. A produces BA. Then I can tell that this is a left linear grammar. Why? Because in the RHS part, the first part I am going to have is a non-terminal. So can I have this BAB? No, it is not a left linear grammar. Why? Because it is having 2 non-terminals, and that is present. One is here and the other one is at the end. So that is not a left linear grammar. So a left linear grammar is nothing but here in the RHS part, the non-terminal should present at the first place. Nothing but in the RHS, the first position should have a non-terminal symbol. Then we can call it as a left linear grammar. So coming to the right linear grammar. So the right linear grammar, here also the only we are going to differ only in the production rules. In the right linear grammar, if the LHS produces RHS, the LHS will consisting of only one non-terminal. LHS consists of only one non-terminal. Either it can be any letter. A produces, and RHS nothing but it should have the non-terminal should be present at the right side. In the RHS, the last character should be a non-terminal or epsilon. Anything we can have, or we can also have 0, 1. Anything. A produces AB and A produces 0, 1. So this is also accepted. A produces B. Whether it is a right linear grammar, yes, it's a right linear grammar, because I am going to have a only one thing, that is nothing but a non-terminal is present. So the left linear grammar is nothing but if the productions are in the form of A produces B alpha. Alpha is nothing but it's a combination of terminals. Terminals are nothing but small letters. Here the right linear grammar. Right linear grammar is nothing but here it produces A produces alpha, B or beta. B is nothing but it's a non-terminal, and alpha and beta are nothing but it's a combination of terminals. So the next one is recursive grammar. So what is a recursive grammar? It is mainly used in the recursions, and if at least one of the production having the same non-terminal. There are the only difference we are having in the grammar is the production rules. In the production rules, if any one of the production having the same LHS non-terminal in the RHS part, then we can call it as a recursive grammar. Recursive grammar. At least one production should have the LHS non-terminal should present in the RHS, then we can call it as a non-recursive grammar. See here, if at least one of the production having same non-terminal present in both LHS and RHS, then we can call it as a recursive grammar. Mainly the recursion will generate infinite number of strings. It generates infinite number of strings. Let us see here. S produces 0, 1A or 1, 1. So see here the LHS part I am having is S, and but coming to the RHS part I have A. These LHS I am having S as a non-terminal, and in the RHS I have A as a non-term. So it is not a non-recursive, it is not a recursive grammar. So let us go for the one more production. A produces 1, 0, A or B. So here I have in the LHS A I have, coming to the RHS also I have the A. Nothing but the same non-terminal which is present on the LHS is present in the RHS also. Then we can call it as a, this whole production we can call it as a recursive grammar. So in the whole production, at least one grammar, at least one production should be in the form of recursive grammar. Then we can call it as the whole productions are nothing but recursive grammar. And it is going to generate infinite strings. We can generate infinite strings by using this recursive grammar. Coming to the non-recursive grammar. In the non-recursive grammar, we should not have any LHS non-terminal should not be present in the RHS part in any production. Then we will call it as a non-recursive grammar. A G is said to be non-recursive grammar if no production having same non-terminal present in both LHS and RHS. Then we can call it as a non-recursive grammar. So it won't generate any infinite number of strings. It generates only finite number of strings. See here, S produces 1, 0, A. Here S is the non-terminal LHS part. Coming to here in the RHS part, I have A. So both are different. So it is not a recursive grammar. Here A produces 1, 0. There is no non-terminal in the RHS part. So this grammar is nothing but non-recursive grammar. Why? Because there is no non-terminal which is present on the LHS that is not present in the RHS. So then we can call it as a non-recursive grammar. So here in this what we have learned is what is a grammar and what are the types of grammars and what Chomsky classified the grammars and how the nested circles, how the subsets are shown, and what is a regular grammar and what is a context-free grammar and what is recursive grammar and what is non-recursive grammar and what is the left linear grammar and what is right linear grammar. So here in all these things the grammar is main, and the grammar is nothing but it is consisting of 4 tuples, and we can also call it as a quadruple. G is nothing but pointing to grammar which is going to generate the 4 things, 4 tuples. It is going to generate V, T, P, S. In all these types of grammars the variables and terminals and start symbol are same, only the production rule is going to be different. How we are going to write the LHS and how we are going to write the RHS. That is the only difference in all the grammars like recursive grammar, non-recursive grammar, and left linear grammar and right linear grammar, and the different types of grammars like context free grammar, that is nothing but the type 2 grammar, and type 3 grammar, nothing but right linear grammar. We can also call it as regular grammar. In all the cases, the grammars, the only the production rule is differ, and these all things are same. V comma T comma S all are same, but only the production rule is differ. So this is about the grammars. Thank you.